it like this. Now audible? It should be audible now. I changed it. That is listening. Audible? Okay, load the MNIST data set, and that data set we are loading it with the data sets class that we have taken. .mnist load data function will load the data of handwritten characters. Okay, and that data we are going to divide them into training images and training labels, test images and test labels. Normalize the pixel values to range from 0 to 1. Train images, test images, and then we are dividing them with the 255. Train images divided by 255. We just wanted to see how many images we wanted to have and divide them into normalize the pixel values to range from 0 to 1. That is your order of matrix or order of the image that you have taken, and add a channel dimension to the images required for CNN input. Your channel dimensions are, if it is a black and white, it is having zeros and ones only. Okay, for that pixel, we are going to say that it ranges from 0 to 1 that we saw earlier. It was ranging from 0.0 till 1.0. Okay, for the black and white. Presently, we have taken black and white itself as a data. So that we are trying to do that. Okay, training images, np.expand dimensions. Have you heard of this method? Expand dimensions? No? Okay. It inserts a new axis that will appear at the axis position in the expanded array shape. It will change the shape of your array and add a dimension to it. Add one more dimension to it. So what it returns? A view of A with the number of dimensions increased will be the return value. So what you are going to give? You are going to give an A, and you can optionally give a string or bytes. In any type you can give it. So presently we have given the image data, that is training images, and axis is -1. And for test data also we did the same. Test images we have taken and expanded the dimensions with the x equal to -1. All of you are getting? Quickly look at it. np.array. All of us know how to create an array using numpy, right? Okay, this is 1, 2. We have x.shape. Is that right? Shape of the array. Okay, what does this shape says?
It's a
one row, 2 columns. Okay, the following is equivalent to x of x, which is this one, having 1 and 2. np dot new axis comma colon, there is no boundaries, or x equal to np dot new axis colon. So y equal to np dot expand dimensions. X is the data that we are giving, and we are saying x is equal to 0. Then we will be going to get this one as 2 dimensions. I mean, one more dimension has been added here. Okay, with existing dimension, one more dimension has been added. So that's what expanded dimension is doing.
So there was 1D and 2 elements.
1D and 2 having 2 elements.
Yes.
Yes, 1D and 2-dimensionally. How about this one?
1
Is trying to give you the shape of the 2-dimensional matrix, and here we have made it axis 1. So now it is having I mean, when you print the array, it has given you the two different elements are being separately added into one of the brackets. So now it is having 2 cross 1, 2 rows, 1 column. How about this one? 0, 1. Axis 0, 1. We have a 3-dimensional array here being created. 3-dimensional axis has been created. I mean, 3-dimensional matrix has been created. 2, 0. It is giving you 3 brackets, but with the individual elements. Okay. Some of the example may use none instead of new axis. There are some objects available. So what it is doing, it inserts a new axis that will appear at the axis position in the expanded array. So that's what we are trying to do in this one with the data. Okay. How about axis equal to -1? Axis equal to -1. We saw a 0.
This is the basic line. So if expand that will become -1 will become 0.
Yes. Can you check in your PCs? Only one numpy will import the numpy. Import numpy quickly. Import numpy as np. Import numpy as np. And then use x equal to np dot expand underscore dims. Is it done? What you got with the -1? You take a you take the data here itself. You can directly take, or you can create an array with the numpy. You can create an array. That it is easy for us to submit it to the neural networks. Okay, so this is converted to one dimension now. All right, it's one dimension only. Only one row is coming for -1. Right? Two rows we have one column. Two rows, one column. So one column means vertically we are arranging. Vertically we are arranging. See, we saw earlier with the help of a video.
One set to brackets
Okay, one.
and close the
One bracket opens, sir. Two bracket closes.
Then it is one column.
and
One column. Two rows. One column is two rows. Class with different neurons will receive different pixels. So this kind of a photo, if I take it, converted between the 0 to 1 only. Black to black and white. White will be the pendulum, then 1, 0 will be black. In between values will have in between values of 0 to 1. You can open the Excel sheet and see how many columns are there. Okay, we can only do that by reading the documentation of MNIST. All right. So that way, we need to know that how it is going to be structured permanently, and then we are going to add that structure. So now, presently, we just consider them having the the two-dimensional data, and we wanted to convert them into one-dimensional data. Okay. Convert the labels to one hot encoded vector. We are going to encode them to an encoded vector. Training labels. Now we are using this CNN in a supervised mode. You can also use them in unsupervised mode in the supervised training mode. Here, which is my TensorFlow dot keras dot utils to categorical. That means we are going to go with a categorical type of algorithms. Training labels, comma, number of classes, how many? So it has to look for only these labels for their outputs. If they want to say any output, so in this label they have to choose what is their output. For test also, we have test labels for numbers, same it is for test label also. Now the training labels and test labels, they will be same, but look at the training images and testing images, they will be different. Alright. Now once we do this one, we will be able to display them or print them here itself, so that they can be seen before we use them. Alright. Before you use them, you can display them, display the image how they can look for. Then you can go ahead with using them. We'll just display them. Okay, we are just converting labels to one hot encoded vector. That is one vector they are converting. This is my one-dimensional vector. Then we are going to use the models. So this much is my data preparation. We have taken the data and we are converting them into specific dimensions, and we are keeping them in a black and white range by dividing it by 255, and then we are increasing the dimensions from -1 to -1 by 5. -1 we are making it only one column to be available, so that we can assign each value of the pixel to the neurons properly. So that has been done and added into the train images. And here we are going to have the training. Yeah. Because that is the range of number that we have for the colors. If I tell you you want real demo? Okay, this background of this Google's search box is okay. If I take this thing as one of the, I look for this color, and as we are talking about color itself, and I'll pick this color. Oh, yeah, here I have. I can take this RGB and I can see that this is my maximum color. This is my maximum value. You don't have any effect on your colors if you increase that. It is 255 maximum. I am increasing the number here, but that number is not changing. It is maximum, it is taking only 255. Now it is changing, but if you change it again, it doesn't change. I mean, the color that you see can only be taken till here. If you reduce it, you can take it. The color is changing, you can see. I'm just reducing the number. Alright, this boundary is related to that only. Now I'll go back to black. Alright, this is -1. Okay. How can I make the color black? what values I can add for RGB?
Keep everything zero.
0. This is ambient. A is ambient, transparency. If you see any Apple's or Mac's interfaces, they will be transparent. Their ambient is being reduced. Maximum 1 means it's opaque. That means completely opaque. Wait, not yeah, opaque. So if you want to make it transparent, you have to reduce that 1 to 0.5 and little transparent. If you make it 0, completely transparent, totally sensitive. That way you can use that ambient. Alright, that's one. So we are not going to press that, we just going to do this. So presently we are at 0. So how can I go from white to, black to white? What values I can change here so that I can get the white color?
Make everything different.
65? Yes. He said the answer now. Now it is completely white. Alright? So we are going from 0 to 1 by dividing 255 exactly. Got it? Okay, so till here we just prepared our data for the model. So further we are going to use sequential to prepare our convolution layers. Again, we are preparing the data itself. What we are doing in convolution, as we learned earlier, what was the process called convolution process? Reducing the pixels and preparing it for neural network. So presently we are not touching any neural network concept here. We are just still preparing the data itself in this also. Alright. Those processes that we saw in the diagrams yesterday, all those names you can see now. Alright. So we saw yesterday the name called convolution in 2D. Convolution in 2D, 3 times we have taken, and we have taken max pooling. We have not heard about and explained about max pooling or pooling. We have not discussed it, right? Yesterday. Okay. So max pooling is taking a mean, not the mean, the maximum number out of a matrix. For example, I take 2 cross 2 matrix. In that, I will fill some numbers. Whatever the maximum number is there in that 4 numbers, I will pick that number and create one pixel of with that number, highest number. For example, I have 1, 2, 3, 4. Maximum value is 4. So I'll pick that 4 values and I'll keep it in the resultant image matrix. Alright. So why we do that is the first question. We do that to preserve the important information in the targeted image. Alright. In that whole target we have to consider in the image that you are going to be using in the machine learning. In that area, which are the pixel value, which is the pixel value which is having highest value, which is storing maximum information of that area. That will be picked so that we should not lose the information. Important features of the image we don't want to lose. That's why that process will be followed every time once you do convolution. Alright. When you are reducing the what you can say size of the image, it is possible that you lose the important information. So immediately after minimizing the photo size, so you also do this max pooling every time. Alright. So just imagine I'll take out the photo and just give me a minute. Just imagine I'm just taking a photo and I pick the GIF, max pooling, GIF I want. We take this one. This is good actually. cooling layer, this max cooling, 1329. So 9 is picked out of 2111. 2 is picked. Then we'll go for this one 1356. We'll pick 6, and we have 1, 2, 3, 2. We have 3. That 3 will be picked. Okay. Now, if you see, if this is little darker, this is lighter, and this is lighter, and this is more lighter, so this is dominating pixels of that region. So dominating pixels will be taken and gathered so that the original image features are preserved. All right. Okay. So that will be done, and that is nothing but max pooling we call it. All right. One more image we have. This is max pooling. This is average pooling. Max pooling take the highest value from the area covered by the kernel. Okay. What your program is using? This one or this one? Max pooling. Yes, we are using max pooling 2D. Two-dimensional. The area covered by the kernel. Okay, so this is my kernel that I am using. Okay, this is 7, 3, 9, 3. Obviously, 3 and 3. Here, what is changing? So you can see kernel size is 2 cross 2 and stride is 2 cross 2. Okay, we are not told what is stride. Let's come back to this later. Average pooling, calculate the average value from the area covered by kernel. Calculate the average value of all of them. How do you do calculate average? Convert feature 4 cross 4. Is that right? Average values. Do the first one 327.
6 by 4,
12 by 12 by 4. 12 by 4 is 4, but there will be 3. Next, how about 5209? 4 is correct answer. How about last one 3023? 2. The top one 0013. 4 by 4. 4 by 4. That is 1.
3 plus 3, partial C of 8.
First 3 is also correct. 12 by 4. Okay. So I hope you understood both of them, and you understood the reason behind why we are doing that. Okay. Actually, you'll understand it later if you get the output. But presently, the process you understand. Okay. We understood the kernel, which we are considering as a box. How much bigger that box is, that we are telling in terms of rows and columns. So 2 cross 2 is my box that I am considering. That box which is moving, we are calling as kernel. This clear. Next, strides are the the area that will be considered when you are doing this process. Will be 2 cross 2. All right. Strides, you can say that we also have the concept called padding here. Padding are the edges of those matrices that we will be considering, and in most of the cases we do not consider the edge values of the matrices in the photo as a borders. Okay, if I want to avoid that, I will consider padding. I will give the one of the parameter in my algorithm that I will give you the image, but do not consider this much boundary of all the image boundaries. You don't consider it. So I can guide my algorithm by giving that padding algorithm, by padding of that, and from where it has to start and how much the size could be from the start. So stride will tell you that. All right. Okay. Stride is a parameter of neural networks filter that modifies the amount of movement over the image or a video. For example, if the neural network's stride is set to 1, the filter will move 1 pixel on it at a time. So what in terms of this one, what do you understand? 2 cross 2 is my stride. So how should I move it? See, one more thing you can understand. If I do not specify the stride, so I can also tell these are my hyperparameters. Try to seriously look at it. So, for example, if I have like this, then now if you try to implement the same stride, same movement, you try to do it here, and tell me how do you do it? Movement you are doing, right? 2 cross 2. You took this one first. Now move. You are telling me to move. You are telling me to leave only this much. You start from here. What you told me? You told me leave only one. If it would have been the case like this, then what you would have been told? You tell me to do this one also. That means you are telling me totally you leave to here. How about from here? You also tell me this is my 2 cross 2 stride. This is the movement that you are doing. Got it? That's how it has to be understood. Then leaving that 3 2, immediately that jumping to 0 0 0. That's what the jump is there. And this jump, I mean the stride and that padding will work together, because from where should I start? And okay, as I'm jumping, I may jump in the boundaries also, but I have to ask my padding how much padding you have and where should I move. In this space only you have to move. The data is bigger, the matrix is bigger. From where should I start and where should I stop? Other thing is actually the margin of the paper. A4 size paper, we have margins, right? So that way we will be having the margin for the data. We can provide that. Is it okay? Yeah. We have the model that is sequential. We have convolution 2D that is 32, 3 cross 2. Okay, let us have the reference for this one. We have the layers. I hope you understood the layers. We are trying to create the layers of the existing one. Uh, 2D convolution layer is a spatial convolution over images. This layer creates a convolution kernel that is convolved with a layer input to produce a tensor of outputs. So, if you understand what is this, it produces a tensor. It is saying, what does it mean by tensor? We just now installed TensorFlow package, but now it is saying it produces something. Convert with a layer input to produce the output as tensors.
It creates a 4D outputs or a series of matrices.
Matrices. It is a matrix. Okay, of whatever dimension it is going to produce. Got it? Yeah, that's it. X, Y. That's matrix, obviously. It's talking about the matrix itself. That is 3 cross 3. It is its kernel. This is my 32 cross 3 cross 3. Have you seen this kind of numbers? I mean, have you seen the size is becoming smaller, the image is getting smaller? Have you seen that diagram? Okay. These are the numbers. We have not written there, but we have written them like 32 cross 32, 64 cross 64. Have you seen that? You might remember it. I'll just give you some visuals. Yeah, we have something here. We saw something like this. So all these names and keywords that we have here, we have them in the program. We have this. Okay, here the numbers we have taken from MNIST, and that we have divided them and made them available for us. And for the MM channel, for the first layer that you have created, layer dot 1 to B, there you have mentioned 32 cross 32 cross N1. N1 is my number of layers that we are not considered, and we told that it is 3 cross 3. Here it is taken 5 cross 5. Our convention is 3 cross 3. All right. So we'll decide that. Kernel valid. Okay, this one is valid padding with the valid padding, and we have max pooling of 2 cross 2. What we have here in our program, we have 2 cross 2. You understand that? Okay. Then we have the same kernel size is same. Here we are changing. Here it is 24 by 24. Here we have 12 by. So here we have increased it. I mean we kept them same. 32 it is there, and then we have 64, then 64. Then we have for dense it is being 64 and again 10. These are your activations that's been done for considering those values to be available in the next year, or to be available for the next year to be given as input. Okay, focus on this one. 3 cross 3, you understood this much. Next activation, what is RELU? It is activation function, which is acting on each of the values what it is providing. I mean what it is giving output. Input shape is 28 cross 28 cross 1. So what is this 1? Layer 1. So this is the layer 1. So we will get you started from there. So next we have max pooling. What it does?
It will consider 2 rows and 2 columns.
It reduces that range. Okay. Convoluted values, it is going to reduce it to 1. It takes 2 cross 2, like it is taking, we are taking 4 numbers. Same thing, it is going to. Then we have the convolution with the 64 values, then 3 cross 3, then activation RELU. Then same thing for this one as well. Here also, we are going to have the activation function. Then we are going to flatten it. So why do we flatten it? Yesterday we saw that we flatten it.
Reducing the dimension.
Exactly. So reducing the dimension to 1 dimension. Then after that, this is my final step actually to convert that. And at last we are going to check the density of that. 64 dense will actually give you the depth of the neural network also. The activation equal to RELU, then softmax. What does softmax do?
Activation functions.
Yes. So what's the work of that? I mean, how does it look? Have you seen that? Since it is available here, I'm just trying to give you that picture here. Similar to your sigmoid. Yeah, similar to a sigmoid, but the range here is starting from 1 till the 10. Okay, and it also includes the minus and plus values. But earlier we saw that it is only taking the positive values and okay, it is considering both of them. And at the end, once we are ready with the model, and now presently the question is. What we did here is the question first. You understood internally? So why is the question? And what we did? The again the question. Okay. Okay, so till here we are flattened, till here we reached. This process we completed. Okay, the complete process. So now we need to go for all right. Okay.
So now we reach the first layer, sir, that is input layer.
Yes. Now we just prepared the data. Now we need to go ahead.
So it's like loading the data into the first layer of the algorithm.
We are not loaded it yet. We just prepared it. Okay. Then we are going to compile this existing model, which is my sequential model. Then I'm going to compile it here. Optimize with the Adam and loss categorical cross entropy. I'll be going to look at it, and metrics accuracy I'll be looking at it. Earlier, while evaluating, you were actually doing adding these kind of functions and trying to get the values. So presently, we are just trying to give them the values itself, what we are going to use for checking its accuracy, and then we are going to train it. This model itself, what we have just now created with the data, that is going to be compiled with this model, and now model is ready with the data. I mean, with the model, we are not given any kind of input data to this one, so it doesn't know what data is currently. We just prepared its configuration here. All right. So that configuration is also added with this what you can say parameters which are going to be evaluating those answers of that. Okay, and they will also analyze how do we optimize the layer. Okay. How about this one? What we are trying to do here? Yes, we starting the training, train images and train labels and epoch. So have you heard of this one? 10 iterations we have chosen. So how many iterations you want to do? Based on that, time will be taken. That much time will be consumed. Okay, this much we understand. Batch size is 32. Batch size 32. Then validation data, test images, and labels. Validation will be done along with the training. Once it is done, then we are going to have evaluation, test images, test labels. You are going to display these values with this one. This evaluator will check by itself. You don't have to worry about how it is going to check. It will give you all the parameters which are standard parameters. If you want to customize it, obviously you have an option to customize it. Then we are going to display all the values. So till here it is finished actually. This is okay. Till here it is done. So we're just trying to evaluate how accurately it is being constructed. All right. Then we have plotting history, history of accuracy. Then training accuracy will be the label. Value accuracy, that is validation accuracy. That is validation accuracy will be the label. Then epochs will be the X labels. How many 10? Accuracy. Then legend will be the heading of that, and will be showing it. Where can we share this to you in the GitHub? I think my package is not installed. I have to debug it. Let's play it. We can execute this. In cold storage. It's public, you can directly access, you don't have to log in. github.com/pionixx. github.com/pionixx.
CNN, sir.
There is a cnn.ipynb file inside the M6, epd_M6.
DPT M6 is
DPT underscore M6. Yeah, there is the program.
it shows in some other format.
Come back, sir. Back. Okay. Back. Back. Get into the DPT underscore M6. You should not click there. Click on that. Click on my file. When you click on the comments, it opens the history. Click on the file and we'll get it. Okay, it started downloading my database from MNIST data. It started downloading, and it is still executing. So it's building its own network and it takes some time. Your normal programs don't take this much time. It is taking 3 minutes presently to download it. And it started its deposit, it is training it, and the loss and accuracy it is displaying concurrently, and 10 times it does the same.
So we need to copy and paste.
Execute it fast. Not installed. You can just check initially the accuracy is less, then the accuracy will be more. And once you go on training it, training will increase the accuracy, just focus on accuracy. It increases the accuracy. Program is actually trying to recognize the digits and trying to take it.
So this model we can use it. So we should click on this IoT website. Because I have not clicked on this website.